Spiral matrix number 4 is Leetcode 2326. So here's the question. So you're given two integers which are m and n, which represent the size of a matrix, with m being the number of rows and n being the number of columns. You're also given a linked list with a head that is head. And then you're supposed to generate a m times n matrix that contains the integers in a spiral clockwise order. If there are remaining empty spaces, we fill them up with -1 instead for the matrix. You are kind of guaranteed that the size of the matrix will be enough to cover all the elements in the linked list. So here is what the output is expected from us. So we have a linked list here with its head being 3, and if you trace down the linked list, it will go from 3 to 0 to 2 and so on until it reaches 0. So how do we fill the matrix following this linked list? We start at index 0, 0 and fill it up with 3, and then we go to the right, as you can see in the top right arrow. So we fill the first 5 elements, and after that is done, then we go down, as you can see in the down arrow on the right, and then we fill up 1 and 7. As the bottom has been reached, we now traverse left, and then we fill up in order 9, 4, 2 and 5. And then after that is done, we go up again, but we stop at the first or at the second row, and we fill up 5. Next, we can move right, but we only have one element in the linked list remaining, which is 0. So we only fill up 0, which is, as you can see, in the second row and second column. The other two elements in the second row are set to be -1, as as the linked list is too short to fill every space in the matrix. So what can we see from the question? So there are only two types of movements, right? Right and down, and left and up. If you see here, we move from right, down, left, up, and then right, down again. But down wasn't required because we're not moving, because there's no need to move down anyway. So these are only two types of movements, and we know exactly how much we need to move in each direction. Like, let's look at this example, right? So we have a linked list here. So the first right movement will cover the first 5 elements, and they'll be added into the matrix. Then we go down, and we cover the 2 elements, 1 and 7. And then we begin our left operation, which covers the next 4 elements. Notice that 4 is 1 lesser than the elements covered in the previous right movement. If you remember the previous right movement, we covered 5 elements here, but now we cover 4. Notice that in the next up movement, we cover 1 element. Note that 1 is 1 lesser than the number of elements covered in the previous down movement. If you remember the previous down movement, we covered 2 elements here, but now we only cover 1. And then we have, after the up movement is done there, then we go right, and we can cover 3 elements, but note that the linked list ends by the time we finish covering the first element, which is 0. Notice that 3 is 1 lesser than the number of elements covered in the previous movement. Sorry, that should have been left. Yeah, there's 4 elements covered here, but now it's going to be 3. So we can kind of tabulate the number of elements covered in each movements. So if we notice, right, if we just look at the right, left, right movements, they go in a decreasing order from 5 to 4 to 3 to 2 to 1 to 0, right? And in a similar way, down, up, and down movements go from 2 to 1 to 0 in the number of elements covered in a decreasing order, reducing by 1 each time. Thus, we can kind of see that the count of movements drops by 1 with every combined movement. A combined movement is right down together or left up together. So let's see how we can solve this problem using the code. So first we create our result matrix, which will which will initially set to -1 for all the rows and columns in the matrix. And then we create a boolean value called boolean right. So this is a boolean value that will tell you whether you're going right down or left up. Also, you initialize a variable called horis and set it to be the number of and set it to be n, which is the number of columns in the matrix, because that's how much you can move from left to right in the matrix, right? So number of columns. So initially it's 5, or like in this case n. And we also initialize a variable called vert, which is how much you can move vertically, right? So initially, let's say you the matrix has 3 rows, right? So maximally you can move 3 times. But notice that when we cover the first right movement, the last element in that row will already be covered. So we can only cover 2 more elements in that column. That's why vertical will be initially set to m-1. So you can only move 2 times after there have been 5 movements from the left to the right. We also initialize our current point in the matrix, which is where we start from. We set current R to be 0 and current C to be 0. It's running on the top left of the matrix. So how do we proceed to move to the right? So this is our main while loop. So we have the first if condition here, which is going to be boolean right, which will check whether the current movement that we're doing is either right down or left up. So first we fill up at the current index in the matrix, which is result current R, current C. We set it to be the value of the head of the linked list. Then we set the head to be head.next as we traverse to the linked list. And notice that since we've already filled up one of the required horizontal counts, we only need to iterate through horis -1 times. So in that case, we had original horis of 5, right? We already filled up 1, so we only need to fill up 4 more elements in that right movement. And here we can see that if not head, we break out of the loop. So why we need to do this is because the linked list, like its total amount of elements might be shorter than m times n, right? So in that case, we just break out of the loop and return the result array as I've already filled up every element in the linked list. And now we need to traverse to the right, right? So when you're going to the right, you need to increment current C by 1, right? So you set result current R, current C plus 1 to be the value of the current head. And then you move the head pointer to the right, and you also need to change current C by 1 as you're traversing from left to the right of the matrix. So let's see the down movement. So this is immediately after the right movement is complete, right? So we have to change current R such that it is current R plus 1, as we are now going to the second row. Let's say if you don't do this, right, then what happens is that it will overwrite the current value in the row, and we need to move down 1 row, right, to begin the down movement. So throughout the entire matrix population, we need to ensure that we do not overwrite our elements and always start at a new row and new column. Okay, so if head, which means if the linked list is still not empty, we fill up the current row and current column with the value of the head, and we progress the head pointer to the next. As similarly explained previously, we break out if the linked list is now empty. And also notice that we only iterate through the loop vert -1 times, as I've already filled up the first element of the down movement. So let's say if we needed to move 2 times, but then we filled up once already, then we need to fill up 2 minus 1 times, which is going to be 1 times, right? So we fill it up 1 time. So similarly, we also, if the linked list has no head, we break out of it, And to traverse down, we simply have to just current r plus equals to 1, which increases the row by 1 each time. And we set the current value in the and we set current r currency in the matrix to be head dot value, and we progress head to the next element in the linked list. And here is what we do to update our variables. So we set horis minus equals to 1 and vert minus equals to 1, as explained during the previous table, on why after every compound movement, which is up down in this case, horis and vert minus equals to 1. Yeah. Also, we need to change boolean right to not boolean right, as we are now shifting from a right down operation to a left up operation. Also notice that we need to set currency minus equals to 1, as we now need to start from one column on the left of the current column. This will ensure that our left up operation will not override the current results from the right down operation. Okay, so this is a case where we are doing a left half up operation. So it's very similar to the case in the right down movement kind of thing. So let's analyze the left movement first. So we initialize the result current r currency to be head of value, and we move the head pointer to the right. And then, as explained earlier, we need to go to the left of the matrix horis minus 1 times, and yeah, we decrement the current column minus 1 by 1 as we're moving from the right to the left, right? So the column number reduces by 1 each time we do that. And then yeah, you pretty much update the result matrix with the current value of the head. Then head progresses to head dot next. This is the up movement. Notice for the up movement, we need to decrement the current row that we are in by 1, as the up movement should not override whatever we have done from the left movement, right? So if there is a head, we populate the current row, current column, and the result matrix to be the head's value, and we increment and we shift the head pointer 1 to the right. And also as explained earlier, we need to go with the for loop with the range of vertical minus 1, as one element has already been filled up in this up operation in the if else statement, right? Here again, we also have a if not head condition to check whether the linked list has been already filled up. And yeah, to move up, notice that we need to reduce the current row by 1 each time, and we fill up the result matrix with the current head's value, and we progress the head pointer to the right. Again, we do need to update the variables, which are horis, vert, boolean right. So now it would have been false, so now it would have been true, right? And we also need to adjust the current column such that its current column plus 1, as a start operation needs to start from one column after the end of the up operation. So let's look at the time complexity of this question. So the time complexity is going to be m times n, as we do require the creation of a m times n matrix, and the creation itself needs to run, it pretty much is complexity of m times n, as we need to create, as we need to like input minus 1 into every space in the matrix first of all. Like even if some of them aren't going to be filled up, we need to fill up the matrix all with minus 1, so it's going to be m times n. So space wise, it's also going to be m times n as well, as we are pretty much creating and returning a m times n matrix. So yeah, so that's the end of today's question. Thanks for watching. Hope you liked it.